The dual timing belt transmission system is being fine-tuned. The mechanic is arc welding to reinforce the electric motor mount, drilling a hole through the composite hull to install the transmission assembly. Moving on to the woodworking stage, the plywood sheets are measured. Spraying paint, applying an epoxy primer and a blue coat on another hull. Test fitting the motor assembly into the blue hull, marking the curved profile lines on the sheet of waterproof plywood. Using a jigsaw to cut along the complex contours. Using the curved parts cut out with high precision. Starting to assemble the side bulkheads to create the basic frame structure. Using specialized glue to bond the wooden edges together. Bending and pressing the deck plywood to follow the curve of the bow. An angle grinder is used to trim the excess wood along the edges. Assembling the transverse bulkheads to form a solid box structure. Aligning the longitudinal stringers using a U-shaped aluminum straight edge. Applying polyester composite resin primer over the entire frame. Cutting PVC pipe sections to create buoyant structural ribs. Applying a white primer coat to protect the plywood surface. Evenly spreading fiberglass cloth to cover the entire hull interior. Placing half PVC pipes along the bottom to increase longitudinal stiffness. Applying a layer of red tinted composite resin, pressing the fiberglass down firmly. Moving on to the Catamaran hull, continuing to apply the exterior composite primer. Thoroughly rolling the outer fiberglass layer to completely remove any air bubbles. Using a saw and chisel to remove the wooden strips shaping the hull edges. This process reveals a perfectly smooth composite edge. Applying narrow fiberglass strips to the chine of the boat to enhance impact resistance. Pouring a resin mixture to seal the sharp edges of the hull. Continuing to roll liquid resin evenly to fully waterproof the interior compartments. Attaching the transom reinforcement plates in preparation for drilling the shaft hole. A hand router is used to cut a wide slot along the center axis of the lower hull. Inserting the propeller stern tube, made of alloy, into the newly cut slot, then applying fiberglass and specialized resin to lock the shaft tube in place, ensuring absolute water tightness. Spraying an even gray primer coat before applying the sky blue paint. Paint covers the entire interior and exterior hull, providing a glossy finish using a pressure spray gun to create a sporty orange section for the bow. Peeling off the masking tape reveals a beautiful aerodynamic pattern. Installing the protective cap and securing it to the end of the stern tube underneath. Assembling the flexible steering shaft mechanism at the stern. The two-blade alloy propeller is securely bolted onto the drive shaft. Returning to the transmission assembly, aligning the U-shaped pillow block bearings. Using an arc welder to firmly fix the two bearings onto the steel base. Tightening the large timing pulley onto the main drive shaft. Two brushed motors are prepared to be connected in parallel. Welding securely and bolting the motors onto the central bracket. Checking the tension of the drive belts for the twin motor system. Manually checking the rotation to ensure both motors are synchronized. The electronic speed controller, or ESC, features a large aluminum heatsink. The technician is carefully wiring it up and neatly securing the cables with zip ties. A universal joint is used to transmit torque. This joint helps eliminate vibration between the motor and the propeller shaft using an electric drill to screw and secure the entire engine mount. The tubular steel seat frame is fitted perfectly into the hull, routing a specialized push-pull steering cable through the rear bulkhead. A ball joint with reverse threads is securely tightened onto the steering edge arm. The other end of the cable is connected directly to the control lever. A minimalist single-axis steering mechanism, but it provides extremely high sensitivity at the push-pull. Action of the cable will steer the rear rudder. A module, the throttle control is integrated right on top of the steering tiller. This allows the driver to control the speed with just a thumb. Installing an additional mini water pump and a diaphragm pump keeps the hull dry. The canopy frame, made of V-shaped aluminum, is erected to support the solar panel. The MPPT solar charge controller is securely drilled and bolted to the side wall. The massive lithium storage battery pack, encased in stainless steel, is carefully lowered to the floor. The ergonomic reclining seat completes the cockpit setup. A close-up of the dual power propulsion system, which uses an exceptionally smooth timing belt transmission. Overall, the mini catamaran features a highly futuristic and practical style. The solar panel not only provides power, but also acts as a sun canopy. The first real-world field test begins on a calm lake. Thanks to its sharp twin-hull design, the boat glides smoothly and cuts through the waves effortlessly. With the quiet electric motors, the only thing you hear is the water flowing past the bow. A wide steering angle allows the watercraft to maneuver flexibly in narrow waterways. Drone footage shows the full view of the boat operating amidst an aquaculture area. Cruising speed is highly stable, running entirely on eco-friendly green energy. The wake leaves a perfectly straight line, proving its perfect balance. The aerodynamic design helps the boat glide smoothly, minimizing water resistance. The single lever steering system responds extremely accurately to every shift in body weight. The horizontal stability of the twin hull structure is maximized during turns. Speed is maintained consistently thanks to renewable energy from the roof solar panel. The dual electric motors run reliably with zero emissions, making it ideal for ecological waterways. The real-world test proves the impressive performance of this custom-built electric propulsion system. Moving to a new project, high-density EP's foam blocks are brought in for measuring. The builder cuts and glues the foam boards together to create a solid raw block. Specialized glue is applied evenly, using bricks for compression to ensure surface adhesion. a flexible wooden strip, is used as a curved template to sketch the aerodynamic profile. A custom hot wire cutter is built using wooden pieces and a spring tensioning mechanism. The nichrome resistance wire is fixed at both ends, ready to connect to a high current power source using an arc welding machine. As the power supply, it heats the resistance wire to cut right through the foam. The hot wire cutting technique leaves a smooth, clean edge without crumbling, unlike using a mechanical saw. The foam block is now shaped like a surfboard, ready for the next step, applying a load-bearing composite reinforcement, laying out the fiberglass mesh evenly. Epoxy resin is strictly required to avoid melting the foam structure. A roller is constantly used to squeeze out air bubbles and press the fiberglass tightly against the core. This process creates an outer shell that is ultra-rigid, ultra-light, and completely waterproof. Once the top surface has fully cured, the hull is flipped over to apply composite to the bottom. Moving on to the drivetrain components, a propeller shaft housing assembly made of metal is being fabricated. The welding machine is used to secure the directional fins and shaft support to the stainless steel flange. On the universal lathe, the machinist is machining and threading the steel drive shaft. The flange components and housing assemblies are also precisely milled from solid aluminum. The stainless steel drive shaft is inserted into the housing tube, which is already fixed under the hull. The Xive gearbox housing assembly is then fitted perfectly to the newly machined flange. This special bevel gearbox will transfer power from the longitudinal axis to the propeller's rotational axis. 4 planetary reduction gearboxes are carefully aligned. The concentric joint of the drive shaft. The internal planetary gear structure helps amplify torque to optimize thrust. The technician uses a hex wrench to tighten the countersunk bolts to secure the gearbox flange. The steel pipe billet is securely clamped on the lathe chuck. They proceed to face the end surface flat. The twist drill advances to bore a precise center hole. Continuously pushing the metal billet, 4 guide pipe joints are arc welded in place vertically onto the square steel baseplate. A steel ring is cut and assembled into a casing to waterproof the internal transmission mechanism, disassembling the head of a broken angle grinder to reuse its internal spiral bevel gears. This bevel gear set plays a crucial role in changing the direction of motion by 90 degrees. The spline drive shaft meshes perfectly with the ring gear, converting vertical motion into horizontal motion. Closing the custom gearbox lid after applying high temperature grease ensures the shaft rotates smoothly. Tack welds are made around the flange to withstand high torsional forces during continuous pedaling. Using a wrench to tighten the lock nuts completes the mechanical structure of the central drivetrain, mounting this entire perpendicular machine base onto the deck of the composite-coated EPS surfboard. Using a handheld grinder to cut off the excess chain rings from an old bicycle crankset, the bicycle bottom bracket spindle is firmly pinned to the input shaft of the grinder gearbox. Mechanical energy from the rider's legs will be transmitted directly down to the submerged propeller system, applying a coat of cobalt blue paint to the deck. creates a UV protective and aesthetically pleasing layer, peeling off the paper masking tape strips. Reveals a red bordered sporty star pattern, pumping waterproof silicone sealant around the base. Completely prevents water from wicking into the foam core. Underneath the hull, the propeller shaft tube is tightly secured. The brass propeller assembly is fixed with a nut. A directional steel plate is welded behind it, acting as a rudder. Installing an ergonomic Eames-style plastic chair creates the most comfortable pedaling posture. Routing the plastic-coated steering cable system mechanically connects the steering lever. The push-pull rod directly transmits linear kinetic energy from the steering lever to the tail rudder arm. Adjusting the cable tension nuts ensures the steering system is highly responsive and not sluggish.
Checking the overall push-pull stroke range of the steering lever on the right side of the seat. The steering assembly and propeller operate smoothly. During the dry test on the cart, this monolithic water bike masterpiece, made from EP's foam and angle grinder parts, is now complete. Its light weight gives the board excellent buoyancy, ready for its practical sea trial. Launching the Watercraft in the canal, the rider starts pedaling furiously to generate power. The solid composite-wrapped foam core dampens waves, easily supporting an adult's weight with great stability. The rotary motion from the pedals is geared up and sent to the propeller through the bevel gear system.